Okay, viewers, now we start solving some examples of reflexive, symmetric, and transitive relation. So this is the very first example. Here we are given one relation. Okay, r is equal to x comma y, where 3x minus y is equal to 0, and this is the set. So we want to check that is this relation reflexive, symmetric, and transitive or not. Okay, so you see that what relation is given to you. You are given that relation where elements are related if they satisfy this equation. Okay, so now basically we check that what are those elements of this set A which are satisfying this relation. Here you have y equal to 3x. Okay, so see, if you set x value equal to 1, what is the y value? Y value is 3. So 1, this element is in set A and 3 is in set A, so it is okay. Now set x equal to 2, so the y value is 6. Set x value equal to 3, what is the y value? Y value is 9. Set x value equal to 4. What is the y value? Y value is 12. As you set x value equal to 5, you see that y is 50. Okay, but this is not the member of the set A. Okay, so only these elements 1 comma 3, 2 comma 6, 3 comma 9, and 4 comma 12, only these elements they come in the relation. Now first of all we talk about the reflexive relation. Okay, reflexive relation. So clearly you can see that here as a comma a, this is not the member of the relation for all a belonging to a. By that I mean that if you take 1, then 1 comma 1 it is not the member of the relation. Similarly, it holds true for 2, 2 comma 2 it is not the member of the relation. So for every a belonging to a comma a is not in the relation. So this relation is not reflexive. Okay, so this relation is not reflexive. I hope you people have understood it. Now second, symmetric. See, for symmetric, you see that 1 comma 3 it is the member of the relation. Okay, but 3 comma 1 it is not the member of the relation. Okay, so as 1 comma 3 is the member of the relation and 3 comma 1 it is not the member of the relation. So this relation is not symmetric. Okay, now next we talk about the transitive relation. Okay, number 3, transitive. So you see that here 1 comma 3 it is the member of the relation, and 3 comma 9 it is also the member of the relation, but 1 comma 9 it is not the member of the relation. Okay, so what does it mean? It means that this relation is not transitive. Okay, this relation is not a transitive relation. Okay, transitive relation. So this is what we wanted to prove. Okay, so in this question we have proved that this relation is not a reflexive relation, it is not a symmetric relation, okay, and it is not a transitive relation. So this we have proved in this question. Okay, now we consider the next example. In this we are given the set z of the integer, and here the relation is defined like this, that a comma b is a member of the relation if a is lesser than or equal to b. Then we want to prove that this relation is reflexive, okay, and transitive but not symmetric. Okay, so first of all we talk about the transitive relation. Okay, see, for transitive you know that we take a comma b member of relation, and b comma c the member of the relation. So as a comma b is the member of relation, it means that a is less than or equal to b, and B is less than or equal to C. So clearly we can say that A is less than C. Okay. For example, if 1 is less than 4 and 4 is less than 8, then obviously 1 is less than 8. Okay. So it implies that A comma C, it is the member of a relation. So this relation is transitive. Okay. This relation is transitive. Now next we talk about symmetric. Okay. Symmetric relation. Okay. See here, let A comma B, it is the member of the relation. As A comma B is the member of the relation, it means that A is lesser than or equal to B. Okay. For example, 1 is less than or equal to 2. But from this you cannot say that 2 is less than 1. Okay. So it does not imply that B is less than A. Okay. So as B is not less than A, so you can say that B comma A, this is not the member of the relation. Okay. So this relation is not symmetric. Okay. Now next we want to talk about the transitive relation. Okay. uh, Now for sorry, next we want to talk about the reflexive relation. Reflexive, see, every element, it is lesser than or equal to itself, and it holds true for all integers. Okay. So it implies that A comma A, it is the member of the relation, and it holds true for all A belonging to Z. Okay. So it implies that this relation is reflexive. Okay. So what I want that you people similarly try to solve the similar type of problem, but you take here a strictly less than sign instead of taking here less than or equal to sign, and think about it that what type of relation is it then. Okay. Now we start the next question. So here in the next question we are given the set L. Okay, here the set L is the set of all lines in a plane, and we want to define a relation R on L by that we say that only those two lines they are in relation if first line is perpendicular to the second line, and we want to check that this relation is uh, reflexive, symmetric, transitive or not. Okay, so it is very easy to check this thing. Okay, see, first thing is this, that no line is perpendicular to itself. Okay, because in order two lines to be perpendicular, we should have two different lines. Okay, so L1 is not perpendicular to L1, it means that, and it holds true for all L1 belonging to L. Okay, so L1 comma L1, it is not the member of the relation. So this relation is not reflexive. Okay, for all L1 belonging to L. Now next we talk about symmetric. Okay, if you want to talk about the symmetric relation, you see that as L1 comma L2, it belongs to the relation. So you can say that L1 is perpendicular to L2. I mean like this. We have this situation that L1 is perpendicular to L2, or you can say that L2 is perpendicular to L1. So it implies that L2 comma L1, this is the member of the relation. So relation is symmetric. Okay, relation is symmetric. Next we want to talk about the transitive relation. Okay, so transitive relation, see, for transitive relation, let L1 comma L2, it is the member of the relation, and L2 comma L3, it is the member of the relation. So here L1 is perpendicular to L2 and L2 is perpendicular to L3, but it does not imply that L1 is perpendicular to L3. It implies that L1 comma L3, it is not the member of the relation. Okay? So this relation is not transitive.